Assalamu alaikum and welcome. This is video number 404, and in this video I'm going to show how to compute analysis of covariance, that is ANCOVA, using STATA software. I'll compute ANCOVA and I'll interpret its results, and finally I'll compare the results of the ANCOVA found in STATA with those results that I found in SPSS. So I'll show that also. So here is an example. I have three variables. One is exam score. This is my response variable. Current grade is my covariate. It is a continuous variable that co-varies with exam score. And studying techniques is my categorical variable. It has three categories. One stands for technique 1 or technique A. 2 stands for technique 2 or technique B, and 3 stands for technique C or technique 3. So I'll be using this data and I'll compute ANCOVA. Now question is how to carry out one-way ANCOVA in STATA. For that purpose I'll go to STATA and I'll open my data file, but this time I'm using another file that I just downloaded from STATA dataset examples, and this example file is NLS88, and there are a large number of variables in this dataset. This is the total number of observations are 2248. So you can see this is a very big file, and there are so many variables in this. I'll be interested in wage as my response variable, union as my factor variable, that is a categorical variable having two categories, union and non-union, and tenure is my covariate. So let me go to the data. Here is my file. So I'll go to statistics, linear models and related, and I'll go to ANOVA and MANOVA, and in this I'll click on analysis of variance and covariance. As I told you, wage is my variable of interest, that is my response variable, so I put it here, and I'll clear this. To click on this, it will give me many facts. So first I will click on this, and my main variable is a tenure, that is continuous. Since this is a continuous variable, so I'll check this box, and it will tell the STATA that this variable is continuous, and after that I'll add this to variable list, and next I will add another variable, and that is union. Union is my categorical variable, so I'll uncheck this, and if I add, so you see tenure means that the tenure is continuous variable. This is the covariate that covaries with my dependent variable, that is wage, and union is my categorical variable. Click on OK, and again click on OK. So here is the command ANOVA, wage, C, tenure, and union, and this is my analysis of variance. You see, this is a regression sum of square or model sum of square. This is residual sum of square or unexplained sum of square, and here are the partial. These are the partial sum of squares for tenure, and these are the partial sum of square for union. So you can see these are the partial sum of square for union. Here adjusted R square is 8%. Sorry, R squared is 0.08, and adjusted R square is also 0.0835, and this is F state for the model. It is significant. Now I will show this information with another method using linear regression model. So linear models, and this time I'll click on regression, and again, as I told you, let me take this out and let me also take this out, and I'll show how to do this. So I'll click on this, and as before, my dependent variable is wage, that is wage per hour and dollars, and for this I'll click on variable 1. So my variable 1 is 10 hour. At this time again I'll click on this and I'll add to the variable. Sorry, I should also take this out. Let me do it again. I had already done that. So I'll write, first I'll write 10 hour. This is my main variable of interest, and since this is continuous, so I'll click on this, and this I will add to this. My next variable is union, and union is a categorical variable, but I will uncheck this, and when I add this, it automatically takes 1 before this union variable. So when we use linear regression method, then in that case the categorical variable will be added by I in front of the variable, and there will be no C in front of the 10 hour variable. But if I use the other method that I previously used, in that case there was C before 10 hour and there was nothing before union. So you must keep this in mind, that in case of using the linear regression model method, there will be I that will be put behind the categorical variable. So okay, and after that I will press OK. Now I have this command, regress wage 10 hour I union. So if you compare this with the earlier, here it is ANOVA wage C 10 hour. So if I use this method of ANOVA, there will be C ahead of the continuous variable and nothing ahead of in the categorical variable. But if I use the linear regression method, then there will be nothing ahead of 10 hour, that is a continuous variable which is a covariate, but I will be written before the categorical variable. Now these results are comparable. You see, the model partial sum of square is 2739.79, and this is again here. Similarly, the residual sum of square was 29702, and it is 29702.36. The total sum of square is 32,442, and again here also it is 32,442.157, which is exactly the same. The R squared value is 0.08545. Similarly, this is 0.0845, and this is adjusted R square, and this is also adjusted R square here. So these are the various values that are more or less the same. This is the root MSE 3.99, and this is the root MSE, and below that I can use, this is the regression model, this is the coefficient for 10 hour, and this coefficient is significant. This is its 95% confidence interval, and this is the categorical variable, which is 1 for union and 0 for non-union. So it means, since this coefficient has a t value of 5.24, so it means this is highly significant. So it means that those people who are member of unions, their hourly wage is higher than the wage of those who are not member of union, and the difference between the unionized labor and non-unionized labor is $1.338, and this is significant. Earlier in another video, that is video number 402, I also computed analysis of covariance in SPSS, and now I did that in STATA by two different methods. One is ANOVA method and the other one is the regress method, and the results are more or less the same. So in order to compare my results in SPSS and STATA, I'll show it here in the slide, and on the left hand side, these are the results from SPSS, and these are the results from STATA, and that analysis was used for the other data that I told you earlier about exam score and about the current grade and the studying techniques. So I just compare the results from SPSS and STATA. So you see, this is the difference between the adjusted means. So this difference is the difference between technique A and technique B is minus 12.514. So it means if I subtract this value from this value, this will be equal to minus 12.512, which is exactly the same here. But here the sign is positive because here I subtract this value from this value, and the difference is equal to 12.5. So this yellow and this yellow are exactly the same. Similarly, the difference between technique A and technique C is equal to minus 7.641, and here the difference between technique 3 and technique 1 is plus 7.641. So these are the same. Similarly, this is the error sum of square, and this is the error sum of square or residual sum of square. These values are exactly the same. This is the partial sum of square for studying techniques, and this is the contrast sum of square for studying techniques. These two are exactly the same. Similarly, the F stat for this comparison is 4.81, and here this is 4.81. Its p value is 0.032 and its p value is 0.0316. So these are comparable. Similarly, the partial eta squared value is 0.466 or 0.467, and this value is equal to r squared value in this regression method. So these results are comparable. In SPSS we get the partial eta squared, which shows the contribution of this categorical variable in in total variable that is due to regression, and this is comparable to the r squared in linear regression model. The overall result is significant because the studying technique, the p value of the studying technique is 0.032. Since this value is less than 0.05, so we can reject the null hypothesis that each studying technique leads to the same average exam, even after accounting for the student's current grade. So it means that the mean exam scores for different techniques are not exactly the same, and that can be seen here. The mean exam score for those using exam score was 88.46, and the difference between the other two is statistically insignificant. So ladies and gentlemen, this is the comparison of the output of ANCOVA in SPSS and ANCOVA found out in STATA. If you haven't yet subscribed this channel, kindly subscribe to the channel and do not forget to click on bell icon. You will get useful notification about my other videos that I'll upload for you. I thank you for watching this channel. Kindly share this channel with your friends, with your colleagues.